Hi students, welcome to the ABK Chemistry channel. So, in the previous video we are discussed about the half-life of a zero order reaction. Now, in this video we are going to discussing about the half-life of a first order reaction. Half-life of a first order reaction. So, before going to discuss about this one, please subscribe the channel and activate the bell notification icon for further updates. Okay, thank you. Now come to the first half-life of a first order reaction. In the previous video we are very clearly we are discussed about the half-life of a reaction. What is half-life of a reaction? The half-life of a reaction is the time in which the concentration of reactant is reduced to one of its initial concentration. That means, for example, you have to take the in a chemical reaction, the reactants will be converted into products generally. Okay, first initially 100% of reactants is there and 0% of products are there. To convert 100% of reactants to exactly 50%. Why? Because half is nothing but 100 to what is half is nothing but 50%. Okay, to convert, what is the time will be take for this change 100% to 50%? That is considered as a T half. For example, 50% to 25%. This will be considered as another T half, like that. Okay, so this is called the half-life of a reaction. Generally, half-life of a reaction will be derived from integrated rate equation. Already we are discussed, and now coming to the discussion about now half-life of a zero order reaction. I am discussing here. Half-life of which order reaction, students? Zero order reaction. What is the? Already I told. Half-life of a reaction will be derived from their integrated rate equation. What is the integrated rate equation for first order reaction? Is nothing but K is equals to 2.303 divided by T log initial concentration of reactants divided by concentration of reactants. 2.303 divided by T log initial concentration divided by concentration of reactants. So this is the equation 1 I am going to taking for it. What is this one, students? Integrated rate equation for first order reaction. Okay. Now what are the conditions for half-life? Already I told, that is T is equals to T half I am going to taking. The time should be taken as a T half. And concentration of reactants, what happens, students? From its initial concentration divided by 2. So what is, if time will becomes to, what is the half-life of reaction means? From initial concentration it should be reduced to half, that is divided by 2. That will be generally considered as concentration of reactants. The time will be taken for that change is generally known as a T half. Okay. Now I am going to substitute these two in this formula. So what we are getting here? Substitute in equation 1. Substitute in equation 1. Okay. Now see here, we are going to observe here in equation 1. In the place of T I am going to substituting T half. In the place of concentration of reactants I am going to substituting initial concentration divided by T. So what I am getting here? K is equals to 2.303 divided by T half. In the place of T I am going to taking T half log initial concentration of reactants divided by concentration of reactants. What I am going to taking here? Initial concentration of reactants divided by 2 I am going to taking here. Initial concentration of reactants, initial concentration of gets cancelled. 1 divided by 2 is there. It will be going to reverse, means log 2 it will be happen. T half I am bringing this side, K I am going to sending that side. So what we are getting here? T half is equals to 2.303 divided by K log 2. What is the log 2 value? 0.301. That is T half is equals to 2.303 into 0.301 is log 2 value divided by K. Now T half is equals to 2.303 into 0.301, that is 0.693 divided by K, and this is a formula for the half-life of which order reaction? First order reaction. Very important, students. Half-life of a first order reaction is equals to 0.693 divided by K. Half-life of a zero order reaction, what we got, students? Half-life of zero order reaction, T half is equals to initial concentration of reactants divided by 2K. In this formula you have to observe here, this is zero order reaction students. Half-life of reaction is directly proportional to initial concentration of reactants and inversely proportional to rate constant. But you have to observe here half-life of a first order reaction. Is there any initial concentration of term here? No, initial concentration term is not there. What is the meaning of that? Means is nothing but the half-life of a which order reaction? First order reaction does not depends on initial concentration of reactants. Very, very important. Very, very important. See, that means if you take any one chemical reaction students, if you take any one chemical reaction, reactants will be converted into products. If the initial concentration of reactants is doubled or reduced to half, we will change initial concentration of reactants. The half-life of first order reaction does not change. Half-life of first order reaction does not change. What is the reason? Because the half-life of first order reaction does not depends on initial concentration. But in the case of zero order reaction, initial concentration of reactant is doubled, half-life is also doubled. Why? Because both are directly relation. Half-life of reaction is reduced to half, initial concentration is reduced to half, half-life of reaction is also reduced. But here initial concentration of reactants is increases or reduced, there is no change in half-life of first order reaction because half-life does not depends on initial concentration of reactant, but it is inversely related to which one? No? Rate constant. It is a first order reaction students. Very, very important. Very, very. For your board examination 100% they will ask question. If the initial concentration of reactants is doubled, what is the half-life of first order reaction? What is the half-life of zero order reaction? Both they will ask. There is a chance to ask any one question. Okay. So this is about the half-life of a zero order reaction as well as first order. Zero order in previous video we have discussed, and this is half-life of first order reaction. Okay. Thank you students. Thank you so much.